All right, here's the last video I'm making for the year. It is for the Algebra 2 semester exam. And we're going to just try to go over all of them. And so if the video is too long, just fast forward it to the question that you want to see. All right, so the first question is asking you to identify the domain for the inverse function of what you see right here. The keyword here is inverse. And if you recall when we learned about inverse functions, they are opposite from the original, from the parent function or original. And by opposite, I mean if you have the domain and range for the original. Let me just write it original. Sorry. The inverse will be opposite. So the domain is actually going to be the range of the inverse, and the range is the domain of the inverse. So that's the part I wanted you guys to remember whenever you answer this type of question. If they're asking you for the domain, then you can translate that to finding the range of the graph. So if we look at this, we notice that there's an asymptote right here on the y-axis, because if you look at it across like horizontally, you notice that this is going up at an angle. Therefore, we can assume that it's going to go up forever and down forever, and range is up and down. So we're going to say B is the answer here, because it's going to go down forever, which is negative infinity. It's going to go up forever, which is infinity. So that answers that. Next question, we have find the approximate solution to the equation 9 equals 3e to the x power. So here we need to, again, isolate the base and the exponent before we undo that. So this 3 is a coefficient right now, and we're going to divide both sides by 3 to undo this coefficient. The coefficient is always multiplying times whatever's next to it. So we're going to divide by 3, and now you end up with 3 equals e to the x power. Here, because we're solving for x, we need to bring down the exponent of x, so that's where we do the inverse of this. So we write natural log, and then we recall this is your base, this is your exponent, and this will be your argument. So when we translate that to natural log, we don't write a base because e and ln are opposite of each other. So then here we write the argument, which is 3. And then we write that it equals the exponent, x. So argument always goes next to the base, exponent goes after the equal sign. And the way this is written, it's as easy as you just typing natural log of 3 in your calculator. And the answer is 1.09861, which is B. So that's how you will solve this question. On the next one, we have solve for x given this equation right here. We're going to use log properties to simplify. And when we simplify, we're going to notice that these two logs are being added. So whenever you add two logs that are the same, you're going to multiply the arguments. So you're going to have 4 times x plus 3, and that will be your argument for the log. And then, of course, 4x and 4 times 3 can be rewritten as 4x plus 12. So that's the new argument. And then now we identify that we have a base, an argument, and an exponent. So we have to rewrite this as base and exponent, and then equals the argument. So it's just back and forth compared to the top one. So base of 2, exponent of 5 equals 4x plus 12. 2 to the 5th power, it is 32, but you can always use your calculator. Let me just change that, and it's 32. So you can write this as 32 equals 4x plus 12. And now we solve for x. So minus 12 minus 12, this equals 20, equals 4x. Divide by 4, so x equals 5. And if you're not sure that these answers are correct, you can always type them in and see if they're right. So for example, this one, it's an approximation, or it could be an exact number. We're going to type it in as an x value. So I'm going to type 3e to the power of 1.0986, and it should give me something almost equal to 9. So it's 8.99, which is pretty accurate. On this one, should be an exact answer, so we're going to just put a 5 in the x right there, and we're going to write log base of 2 with the argument of 4 plus log base of 2, and then the x plus 3, so it's going to be 5 plus 3, and that should be equal to 5. So that confirms that the answer is correct. All right, let's move on to number 4. This one is inverse again, because it has that little -1 next to the graph. So they're telling you that they want the inverse of that. What is the domain and range of the inverse of this graph? So we'll call this the original. So one thing we can do here is rewrite this and mathematically do the inverse, or we can do what we did on number 1, which is recalling that inverses are the opposite of the original graph given, and domain and range are opposites from those. I think the shortest way here is to just graph this and then identify the inverses of the domain and range. So I'm going to type it in, -2 to the power of x plus 2. And that looks like this, which seems to have a horizontal asymptote on the x-axis, and then it is crossing the y at some point. So it's something like this. So right now, if this is g of x, we're going to say the domain here is going to be -infinity to +infinity. So it's like this, or all real numbers. Range for this one will be up and down. Highest, the x-axis, which is when y equals 0. And then lowest is infinity. So lowest will be -infinity, highest will be 0. This could be written as y is less than 0, because it's the numbers below 0. So if we want the inverse of this, we're going to say that the domain is whatever the range for this one is. Based on the annotations, they want the set notation answers, so we're going to write y is less than 0, and the range here will be all real numbers, because that's the opposite of the domain. So the answer here looks like it's going to be B. All right, number 5. Transformations. They give you the parent function, and they want you to describe what happened to it. So A value is always in the front of the log. B value is always on the inside of the input. And then K value is at the end. So right here, we notice that there's a 5 for the A. So when A equals 5. Then we notice there's a H value in there. No B, just H. So we're going to say the H is 1, because if you notice, it says x minus. So just 1 is your H. And then the K is 2. So let's look at the answers. We're looking at A value being changed. That is the horizontal or vertical. So vertical is for A, horizontal is for B. So right away, you want a vertical description, so that cancels A and B. And between these two, now we need to identify whether it's a stretch or a compression. Now, from experience in the lessons we've done, we know that 1/5 only happens when you have 1/b. This 5 becomes 1/5 only if it was a b value, but it's not a b value, so it's not going to be that. Also, we noticed that you have an up to, and I want to say there's a typo here, because let me see. Let me put that 5 in the front, see what happens. So I'm going to graph the original. which is log base 3 and the x. So that's what the original looks like. And then we have log base 3 of x with the 5 in the front. So that's a vertical stretch. So that will be the D answer, vertical stretch. It's definitely horizontal because if it was B, it will be in there. Let's put the x minus 1 to see what happens. So I'm going to go right here, put minus 1. And notice that it shifted to the right. So it did shift right. And then we have the plus 2. So it shifted up. So yeah, it's D. I overlooked the last part. So it's definitely up, not down. And again, H is left to right, K is up and down. If it's positive, it's up. If the H is X minus H, then that means it's going to go to the right. And yeah, so just use the poster on the wall for transformations or use your notes. And let's do another one on transformations. So here we have e to the x power, and 1/3 is your a value because it's in the very front. Then you have e, and if you had a b value, it will be up there with the exponent. So we're going to have b and then x minus h in the exponents, and then plus k. So we have a 2 again for k. And then we don't have an h, but we kind of have a negative b right there. And then the a value is 1/3. So these three things are happening. A is 1/3, b is negative, and k is 2. So from the previous example, when k was 2, it was up. So we're going to say up 2, up, down, down, up. So we know it's not b and c. And between these two, we notice that b is negative. So according to this, reflection across the x-axis, reflection across the y-axis. And we, in the papers and the notes and posters, have that b value is for the y-axis. So therefore the answer is D, not A. And then also, when we do stretch vertically, we don't change by how much. We keep the A value. So this is the A value of 1/3, so that is the answer, letter D. And you can always graph it in your calculator to see how it looks and verify that it is moving the way you want it. But I answered this one just based on the facts that the anchor chart and your notes have about transformations. All right, last two problems on Unit 9. It's asking to solve the following equation. Here we have a log with an argument minus the log with an argument. Every time there's a minus, we're going to divide the arguments. 3x plus 4 divided by 2. So that's just the log property that states this is how you condense it. Now that we condensed it, we are going to notice that on the left side, we have a log with an argument, and on the right side of the equal sign, we have a log with an argument. And if these two are equal to each other, and they have the same log, we can assume that the arguments are the same. So we're going to write 3x plus 4 divided by 2 equals 7x. Now we're going to focus on solving for x in this one. So here we want to undo the division of 2. So we're going to multiply times 2 both sides. And then it ends up canceling the division. And we are left with 3x plus 4 equals 14x. And we're just going to solve for x. X is on one side, numbers in the other. So I think it's easier to move this x to the other side. Minus 3x. And we're going to have 4 equals 11x. And then we divide by 11. And x equals 4 over 11, which is 8. All right, number 8. We have an equation of 3 to this power equals 81 to this power. So I saw a couple of students notice that they can undo using log this part, but if you use log, you're going to have the base of 81 with an argument of 2x, and then, no, the exponent of 2x. So it's going to look like this: log base of 81, argument of 3 to the power of 3x minus 4 equals your exponent, which is 2x. So you notice that you have an argument with a variable in there. And we don't want that, because if you type the log with an x, let me just show you, it's going to tell you error. Minus 4. So that right there tells me error. There's a variable not defined. Now, if you think that maybe we could have done it the other way, where this is the one that turns into a log, this will be the base, this will be the argument, and this is the exponent. We will have log base 3, argument 81 with 2x power, and then equals 3x minus 4. So again, it has an x on the log, so these are not possible. So your other option is to look at the base and ask yourself, can 81 become also the base of 3? So if you use your calculator, you can do 3 squared, 3 to the third power, 3 to the fourth power, and 3 to the fourth power is 81. So if you rewrite 81 as 3 to the fourth power, and that to the power of 2x, we can now rewrite this equation as the bases are the same. Similar to the problem above, the logs were the same, so we focused on the arguments. On this one, the bases of 3 are the same, so we're going to focus on the exponents. So like above, we had log equals a log, then arguments have to equal each other. We're going to say here, if the bases are equal, then the exponents should be equal. So we're going to now just look at the exponents and write 3x minus 4 equals, and then this part is exponent raised to another exponent, so that's a multiplication. Whenever you have an exponent raised to another exponent, the rule is to multiply the exponent. Here we just solve for x, so 4 times 2 is 8x. And then we want to solve for x, so this is probably easier to move over here, minus 3x. And then now you have negative 4 equals 5x. And to solve for x, we're going to divide by 5. So x equals negative 4 over 5. And that answer is right here, letter B. So those were all the questions for Unit 9. We're going to move on to the previous units we've learned. And again, I picked these questions based on knowing that most of the students got these right in the unit exams. So I'm trying to help you here pick up your grade by getting a good grade on your semester exam. All right, so in Unit 5, we talk about solving quadratic equations, and we talked about binomials being either GCF or difference of squares. And in this case, x squared has a coefficient of 1, so there's no GCF. So the next part is difference of squares, which is something squared minus something squared. In this case, x is being squared, and then 169 is a number squared. I already know the answer, but let me just show you. You can either do each number at a time, like 5 square, 6 square, 7 square, or you could reverse. You can do square roots. So if you do square root of 169, you get 13, which means 13 square is 169. So 13 is what you're squaring. So these actually become two binomials. X times x is x squared, and 13 times 13 is 169. But because it's a binomial, that means the middle term canceled. So one has to be a plus, one has to be a minus. And these are the factors, but it's asking to solve. So now you need to solve this to equal 0. When is the x going to equal 0? What x value can you put in there for this to be 0? So this is where you separate the factors and solve for them individually. And this one's pretty obvious, but just following the process. This is minus 13 on both sides to cancel, and you have x equals negative 13. On this one, you add 13 to both sides, and you get x equals 13. So the solutions here is negative 13 and positive 13. And we can write it with, well, here, brackets, negative 13, positive 13. Just make sure you put those brackets because those are the symbols for solutions. All right, let's go to the back. We have similar topic here, solve for the following quadratic equation. However, this is a trinomial. So when it's a trinomial, we're going to still ask ourselves if there's a GCF, but also once we do the GCF, we need to factor the trinomial. And that's where the x helps you. So we're going to have no GCF because the coefficient is 1. And then the x is going to be 8 times c, which is 1 times negative 27. And negative 6 is your b. So the numbers that you multiply to get 27 are 1 times 27 and 3 times 9. And 3 times 9 will give you negative 6 if the 9 is the negative one. So these have to be opposite symbols in order to end up with the negative product. So these are the numbers we're going to use for the binomials for this. So it's x plus 3 and x minus 9. These are just the factors. So similar to the previous question, we have to solve. What x value can we have for this to equal 0? So when we separate the factors, we have x plus 3 equals 0 and x minus 9 equals 0. And we subtract 3 from both sides, so x equals negative 3. We add 9 to both sides, so x equals 9. Those are your solutions here. Or we could write them like this with brackets. All right, number 11, this is unit 6. This is where you determine the product for the following. This is a trinomial times a trinomial. And the way I taught it in class was with the box method. Because it's a trinomial, you're going to have 3 parts on the top, but you also have to have 3 parts on the side. So I'm going to draw a little bigger here. So you could either have the box with 9 spaces and then combine like terms in a very organized way here diagonally. Or you could do one loop at a time. You could do x squared times those 3, and then negative 3x times those 3, and then 4 times those 3. So I'm just going to fill in the box here so it could be more organized. And I'll zoom in since I'm going to write super tiny. So on the top, I'll put x squared minus 3x plus 4. That's the first trinomial. Then I'm going to have x squared minus 5x minus 2. So we multiply x squared times x squared. That's x to the 4th power. Then we have x squared times negative 3x, so that's negative 3x to the 3rd power. X squared times 4, that is positive 4x squared. Negative 5x times x squared is negative 5x to the 3rd power. Negative 5x times negative 3x, that is a positive 15x squared. And negative 5x times positive 4 is negative 20x. Negative 2 times positive x squared is negative 2x squared. Negative 2 times negative 3x is negative 6x. Well, it's actually positive, negative times negative. And then negative 2 times 4 is negative 8. So as you notice diagonally, these are like terms. These are both with the exponent of 3. These are all 3 with the exponent of 2. And then these two are just x. So in order, we're going to start with the highest degree, which is to the 4th power. And now we look at the 3rd power. That's negative 5 minus 3. So that's negative 8x to the 3rd power. If you're not following the box, I'm just going to write the terms up here so you can follow along. All right, so that's what gave us that. And then negative 2x squared plus 15x squared and 4x squared. So you're doing negative 2 plus 15 plus 4. So 15 plus 4 is 19 minus 2, that's 17, so positive 17x squared. Then the last ones are positive 6x minus 20x. So that's negative 14x. And the last term is negative 8. So those are two options of how to do this. You can either do the loops and get individual answers and then combine like terms, or the box. All right, number 12. This one is find the difference between these two polynomials. And the trick here was remembering that when you have a subtraction, you're taking away each one of these terms from what you have. So we can either create like a little column or table where these terms are here, fourth power, third power. There's no second power, so I'm just going to put 0x to the second power because there's no x squared. And then we have a positive x and then negative 3. And we're going to take away, we're going to subtract 2x squared, 2x to the fourth power. And we're going to subtract negative 4x to the third power. We're going to subtract negative 4x to the third power. So right there, writing two negatives, you know it's going to become a positive. Then we're going to subtract a positive x squared. We're going to subtract a positive x squared. And then there's no x here, so no x. And then we're going to subtract a negative 2. So subtract a negative 2, that creates adding 2. We combine like terms, so 8 minus 2 is 6x to the fourth. Positive 4 times plus 4 is positive 8x to the third. 0 minus 1 is negative x squared. 1 and 0 is just 1. And then negative 3 plus 2, that's negative 1. So right away, finishing negative 1, these two, starting with 6x squared, 6x to the fourth is these two. So the one that has both answers is D. And if you notice, the middle terms are also the same. So D is the answer. All right, number 13, it's asking you to multiply these functions with each other. And the first thing you want to do here is factor. If you have a trinomial, you're going to do the big X, A times C, B. If you have a binomial, you check if there's a GCF or difference of squares. So here for this trinomial, we're going to do A times C, which is negative 12. B value is 1. So what two numbers do you multiply to get 12? It's 3 and 4. But in order to get 1, we need to subtract 3 from 4. And these two need to be opposite signs because when you multiply, you get negative. So you're going to have the factors x minus 3 and x plus 4 on the numerator for this fraction. On the bottom, you notice is x squared minus 16, which, again, GCF, coefficient of 1, so no. Difference of squares? Yes, because if you have two binomials, x times x is x squared. And then how do you get 16? You have 4 times 4. So 1 plus, 1 minus. Next, we're going to have x minus 5 on the top. Nothing to factor there. And x squared minus 25. Actually, no. This is also difference of squares. X times x, 5 times 5. Positive and negative. So when we're multiplying fractions, we are going to multiply factors across each other, which end up being all multiplying each other. So it ends up as a big fraction with factors on top, factors on the bottom. And because they're all multiplying each other, we can simplify by canceling the terms that are, or the factors that are exactly the same. So by doing that, I have x minus 3 on the top and x minus 4 and x plus 5 on the bottom. So that results in A. Oh, my bad. I noticed I didn't scoot out and zoom out. All right, 2 more questions. And we have the square root of x being asked to identify what happens to it if we have this transformation. So this is unit 8. Another transformation topic. So A value will always be in the front and B value will be inside and K value will be on the end. So there's no K value because we don't have anything at the end. There is no B value because there's nothing right next to the X. But there is a negative A and there is a minus 4 for the H. So we're going to say H is x minus, so H is just 4. So we need to find which one of these show that. Or, of course, since they're graphs, you can just graph them. So square root of x, if you notice, all the questions have square root of x right here, touching at 0, touching at 0, touching at 0. So all these 3, actually, let me show you all 4. So like this one goes like that. This one goes like that. So these 3 are the square root of x. And I put a question mark on letter B because none of these are square root of x. And I'm going to just show you real quick how that looks like. That's square root of x. So we can cancel out B. Then we look at having a negative value in the front. So I'm just going to put negative in the front. And that immediately flips over the x-axis. So like this one flipped over. This one did not flip over, so turn that one. And then this one also did not flip over. If anything, it reflected across the y-axis somehow. We don't want that. So that results in the letter A being the answer. And it's all just based on these descriptions along with graphing it in the calculator. You can just go back and finish putting the other part, which is x minus 4. And you notice that is matching that because it moved 4 spaces to the right. All right, last question here. We have the same topic, but just no graphs. So we just describe in words. Square root of x is the parent function, and the parent function with the a, b, and h and k will look like this. And when we compare this to what we have, we notice that the 3's inside the square root, so that's a b value, no a. The 2 is the h value, and negative 5 is the k value. So we gotta talk about what those do to the graph. When b equals 3, when h is 2, and when k is negative 5. We can graph them individually as well and see what they do. So I will have the parent function to compare to. So this is the parent function. And if we put a b value that's a 3, we're going to type square root of 3x because that's putting the b value of 3. Notice that the b value made the graph go higher, didn't move it, shifted, nothing, is just stretching it. Because it's a b value though, we're going to say horizontal. And since we're talking horizontally, we are looking at it sideways. What happened to this graph sideways? So did we stretch the graph or did we compress the graph sideways? So this is a compression because stretch will make it lower like this and compression like that. So horizontal compression by, and because it's a b value, we are going to say 1 over b, which is 1 over 3. For the 2, we're going to have not the 3 in there, but instead copy down what you have, x minus 2. And notice that the parent function just shifted to the right. So shifts right 2. Then we have k of -5. So I'm going to delete the 2 and then put outside of the radical -5. So notice that it lowered it. So it shifts down 5. All right, so that finalizes going over the whole review. Hopefully you hang in there till the end. Have a good semester exam.